All right. If you've done the videos in order, you've come to the end of the gradable material for this course. The next couple videos are kind of for more information and some applications. This one is a walk through a number of different groundwater and soil remediation technologies. I do have these notes available for you, but there's really nothing for you to fill in, but you can have them for your reference. And then in a second video, I'll walk through a couple remediation technologies in more detail. Probably the best online resource I've found for describing these technologies is the Federal Remediation Technologies Roundtable. I have the link there in the notes, and a lot of the figures in the notes are taken from this. But in there, it goes through different technologies, and you can filter them by the type of technology and by what contaminants they work on, and it has a whole bunch of them. I'm going to go through some of these and some different categories of these. I'll divide these into a couple categories. Ex situ means out of place or out of the ground technologies, and then in situ. And then I'm going to go through contaminated soil, then contaminated groundwater. There's a lot of overlap there. Matter of fact, I'll present these for contaminated soil and then say most of the ones for contaminated groundwater you've heard already. And then the different types of treatment we can do are biological treatment, physical chemical treatment, and there's a couple other things. So first of all, remediation methods for contaminated soil. One method is just to excavate it and dispose of it, what we might call a dig and haul. So ex situ, out of ground treatment, we take it out and get rid of it. Now, it's not quite that easy. You have to do pre-excavation testing for it to see what's in there, both for the safety of the workers doing it and for the disposal of it. So if there are contaminants in there, which that's why you're getting rid of it, then you're going to have safety precautions for the excavation. So there's a process there. And then you have to find a facility that's permitted to take that contaminated soil. You can't just dump it anywhere or take it to any landfill. One of the methods, the ex situ, you take it out of the ground and do it, is soil washing. So soil washing, there's usually a couple processes here. Size separation. Most of your contaminants are on the fines. So if you can separate those out, you can reduce the volume that you have to deal with and reduce the volume you have to buy. Some of these technologies, there's a photo here. You can wash it with surfactants, soaps, chelating agents, alcohols, depending on what the contaminant is. A lot of them are proprietary. They won't come out right out and tell you what's in it, but that's what's in a lot of them are surfactants and alcohols. So you can wash the dirt and then have clean dirt, and then you maybe put it back or you don't. You haul it off. Another one is land farming, biopiles, composting. They have, in that round table, they have a couple different sections on each of these, but there's similar ideas that you take the soil out of the ground and then you bioremediate it. Usually it's like composting. You can turn it, you can add microbes to it, you can add different things to it, you keep it wet. So you're farming the soil, getting it to clean up. Now, important consideration is if you take it off-site somewhere, now you've taken contaminated soil to that other site. Now you have another site with contaminated soil. So you have to think about that. Incineration, you can take it out of the ground and burn it and burn off petroleum hydrocarbons or fuels, right? So they'll burn off, and then you can dispose of it, which if it's burned off, it's not contaminated anymore, or maybe you'll replace it on site. Now you're burning that off, you have to think about the air pollution off it, and off-gas collection and treatment. All right, let's talk about in situ treatment, in place, when we deal with it. Containment or capping. So the problem with the contamination is it's going to go somewhere and hurt somebody, right? So if you can contain it, put a cap on the top, just dealing with a site like that this week, then you can keep, for example, keep the rain from going in there, keep the vapors from coming out, And you might need side barriers to that and a bottom barrier to it. Similar idea is solidification or stabilization, where you can mix some grout in there or something else that keeps it stuck there. So you solidified it or stabilized it so it's not going anywhere. You can also do that chemically, chemical fixation. You can chemically modify it to an immobile species. For example, chromium plus, which way does it go? Chromium plus 6 is toxic and mobile. Chromium plus 3 oxidation form is non-toxic and mobile. Or do I have that backwards? It's been years since I've dealt with that. That'll be something I focus on in the next video, so we'll come back to that. So you can chemically modify it so it doesn't go anywhere. Soil vapor extraction, one of the most common technologies. That is, what happens to gasoline if you spill it on the parking lot? It evaporates, right? It goes away. So we can use that property. We put in soil vapor extraction wells that suck air through the ground, and then we got to deal with that vapor from the surface. Maybe we need air pollution treatment, maybe we don't. And we can also do air sparging, where we put air down into the groundwater or down into the ground, and that blows air through there, and that speeds up the process. That also increases the dissolved oxygen, which makes bioremediation go faster. So this is one of the most common technologies used. We can think of them as two different things, but often they're used together. Soil vapor extraction, sucking the air out of the ground, air sparging, pumping more air down in there to get it moving through there. Biodegradation, we can enhance that. We can put nutrients in there. We can put oxygen releasing materials in there to speed up that bioremediation. And depending on the contaminant, depends on what we put in there, depends on what the contaminant is and how that biodegrades. Monitored natural attenuation is not do nothing. So do nothing implies that you're not doing anything. Here, you are monitoring it to make sure that it's breaking down on its own. So if you can prove that it's attenuating, it's going away on its own, then you just need to monitor it and keep track of it. Surfactant and solvent washing in our research group when I was in grad school focused on surfactant remediation. Surfactants is like soap, surf detergent. You can put the soap down in there, and the chemistry of it's tricky, or a solvent, an alcohol or something like that, and you flush that through, and then it'll extract out the organic contaminants. And the economics of it depend a lot on if you can recover that solution. Again, this will be one of our focus ones in the next video. Similar idea with steam or thermal treatment. Well, no, those are a little different ones. So some things will break down under heat or under, again, that steam through there, so they can extract it. You can extract this out of there, but you can also have it break down with the heat. So we can put heat down there and or pump steam down there. And for some contaminants in some situations, that might speed up the removal of it and the transformation of it. Remediation methods for contaminated groundwater in addition to soil. So most of the things we talked about above, like the soil vapor extraction with air sparging, that works for groundwater too. But here's some more specifically to the groundwater. And a lot of these under the heading of pump and treat. So we pump water through there, pump water out of there, and then we treat it. And we can treat it through air stripping, carbonate absorption, biological treatment, other. But you pump the water out, you have some type of treatment system, and then you treat the water, and maybe you'll be able to re-inject. It can be hard to get permission to do that, or you can send it off to a treatment facility or do something else with it. But the basic idea is you pump and treat it. And notice here, overlapping cones of depression. So we talked about it, multi-wells, you draw down. So one of the good things about pump and treat is if you're pumping it, you're getting the water to go toward the well instead of off-site. So we can do the same thing with pumping or with barriers. So you could put sheet piling. We talked about soil, about containment, same thing with groundwater. If you put sheet piling out or grout walls, you can keep the water from going off-site, or you can just pump it forever, and then you have the gradient going toward the well and it's not going off-site. So you can physically contain it. Co-metabolic bioremediation. This is another one I'll follow up in the next video. So I mentioned back in the biodegradation video about if you give the bugs ketchup, they'll eat some stuff they wouldn't eat otherwise. That's what we're talking about here. So you can inject a co-metabolite, something that the bugs, they don't really like to eat the main thing you want to get rid of, but if you give them some other stuff, then they'll eat that too. So we call that co-metabolic bioremediation. In situ chemical reduction, one of these is a permeable reactive barrier, and this is cool technology. I worked on one, actually I Googled it a while back. It was not the first one ever done, but one of the first ones ever done of this is so you have groundwater. We had it going toward going toward a river. And what you can do is you can put in a barrier. It's not really a barrier to flow, it's a barrier to the chemical, where the chemical reaction will happen in there. So the chemicals either break down completely or they get transformed into a insoluble precipitate and they settle out. So bad water goes in, clean water comes out. You can do that with a passive barrier where the water just flows through that, or you can inject stuff in there. So the passive barrier, the most common one is iron filings that will put in a reducing environment, and some things, chromium and TCE in our example, will reduce in that environment, or you can inject something in there to do the same thing. So that's pretty cool idea. And there's lots of other ones. I encourage you, I mean, this is pretty gone through just in these 10, 12 minutes. We've gone through a whole bunch of these, but there are some other things you can do. Directional wells, multi-phase extraction. So I didn't talk about what to do when we have NAPL down there. You can try to get that out of there. In addition to the other chemical reactions we talked about, you can do in situ pH control if that helps the situation, in situ oxidation, as opposed to most of these things we talked about are reduction. And even phytoremediation can treat soil or groundwater near the surface. So you can put plants in there that will take up heavy metals, for example, and then you harvest the plants, and then now the heavy metals are in that plant, and then you can process that some other way. So that's a quick run through of some remediation techniques. I encourage you to look more into it if you're interested in it.